All right, let's check this last one out here. This is very similar to one in your online lesson. So if you've already watched that video with the garden, 2/3 by 5/4, then you probably won't need to watch this one again, or you can always go back to your lessons and rewatch them. This will be very similar to that in a little bit different way. So we've got our garden beds here that we want to get ready for the spring. This is, of course, not really a real life situation. It's a math problem, but I am going to make a garden here this year. So it'll be very similar in size to this one. So it's 2/3 of a yard wide by 5/4 of a yard long. To find the area of a rectangle, it is length times width. So let's set up my rectangle here and then we'll label. All right, so I've got my area model here and I've split it up into thirds in my rows. So I have 3 rows representing 3 as a denominator. And then I have it in 4 columns, which represents 4 as my denominator, right? We've got to split it up into the right amount of pieces. Well, to show 2/3, I would shade in. So there's 12 pieces here total. That means that's going to be my denominator. And that's how many parts of a whole. If I had 12 out of 12, that would be one whole, right? So I know that 12 is going to be my denominator here in this multiplication problem. Let's shade in 2 out of 3, 2/3. That would be this portion right here. We run into a little bit of a problem here because now to shade in 5/4, well, I only have 4 out of 4 to shade in, right? If I were going to shade in all of these, that would still only be 4 out of 4. But I need to show 5 out of 4. So let's back up here. In order to do that, one way we could think about it is if we just added a whole nother one of these on, right? We'd still be doing it into 2/3 of it. And then we'd still be splitting it up into fourths because those are my denominators. There's still 3 and 4. So we're still working with parts of 12, right? The 12 out of 12 again would still be a whole. But now I have 1/4 left over. We could think about it like that. Now I have 4/4 represented over here, and we have a 1/4 represented over here. And in both cases, 2/3 is going throughout. So when I do multiplication, I'm thinking 2/3 of 4/4. Again, that word of is very helpful. So the part that's overlapping here, if we can count those squares, that should give us our solution. And let's count them here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 squares out of 12 still because my whole number would still be 12 out of 12. So we can say that that is 10 out of 12. Let's look at that mathematically and we'll keep 10 out of 12 saved. All right, so we could set it up like this. We could use our associative property if you want to do it mathematically as well. We could say 2/3 times 5/4 is the same thing as saying 2 times 1/3 because 2 times 1/3, we can represent that as a model as we did on the second one. And 5/4 is also equal to 5 times 1/4. So if we wanted to do this, maybe the best way to do it would be to do the whole numbers and then the fractions separately. So we could do 2 times 5, and that's 10. 1/3 times 1/4, 3 times 4 is 12. So that's 1/12. And then we could just do 10 times 1/12. Well, 10 1/12 is equal to 10/12. So we ended up in the same spot using that method as well. And of course, these both can be simplified down because they're both divisible by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. So lots of different ways to do these associative properties and also using the model as we did here, or watch your video in your online lessons. They use a model in a little bit of a different way. All great ways to think about these fraction multiplication problems.